Hi, I am Kelly Shanahan on the board of director of Metavivor, and I'm really happy today on I wish we were driving our C2C RV around to different places where we have funded research, but because of COVID, we can't. So we're here on Zoom. Here with Dr. William Schiemann of Case Western University, who Metavivor funded way back in 2014. And he is a PhD in pharmacology. And I just found this out from looking at your bio, but you got your Bachelor's of Science just
I know you're going to go over there
at UN, University of Nevada at Reno, and I live up at Lake Tahoe. So we have that in that little connection there.
Yeah, that was there for 4 years back in the late 80s, early 90s, and then moved on. So
that was before I moved to Tahoe, but Reno has probably changed a little bit since your days there. The campus probably has grown and the city has grown, but there's still mainly casinos there. So.
Yeah, I still have relatives in the area, so, and I agree that I don't recognize campus. The medical school's completely changed. I've actually gone back and saw the guys started with, and it was hard even to find the lab. So
yeah. So we'd love to hear from you about that seed money that Metavivor gave you back in the day, which back in 2014, I'm not sure if it was 25,000 or 50,000, but I know that you were doing work on dormancy, and you did find some targets that seem to be really involved with the process of dormancy and waking up from dormancy. So I'd love to hear about that research that Metavivor helped fund, and also what you're doing now.
Sure. So from those studies, there were two major branches that we really focused in on. One had to do with a long non-coding RNA called Borg, and the other has to do with this idea. It was a protein that had pretty much no known function at the time, that we've since gone on to show that it regulates telomere homeostasis, or regulates how cancer cells maintain their telomeres to stay immortal and progress. I can talk about one or the other, but they're both still ongoing. With regards to Borg, that was a collaborative work that we're still doing with Saba Volodkin here. We've turned that data into a multi-PI R01 that's been funded now. I think it's in year 3. We've had several papers describing it, but the long and the short of it is it's a link RNA, a non-coding RNA, that when it's expressed, it's not expressed in normal cells, and it comes on like gangbusters in triple negatives, and only triple negatives is where we see this.
Really? Only triple negative. Wow.
Yeah.
So can we kind of get back to some basics here for our audience?
Sure.
Long coding RNAs. Can you explain a little bit about what they are? I think we all understand a little bit more about RNA than we used to, thanks to COVID and the mRNA vaccines. But can you explain how something that's supposedly non-coding is actually really important?
Yeah, so what we call a long non-coding RNA. So what we normally think of as our genes really only represents about 1.5% to 2% of all of the genome. So the rest of it is dark matter, or empty space that we still don't understand how it works. And somewhere close to 90% of that is actually functionally turned into something, turned on, but we have no idea what it is. A long non-encoding RNA is one of those. We can detect it in cells, but it doesn't make a protein, but it has a lot of function. How they function is still being determined, but you can think of it as a link looking like a string of pearls. And so they interact with other proteins. And so each of the beads of a pearl, so to speak, would be the length of an RNA. And each one of those beads might be a separate protein that it interacts with in the cell to regulate its function or some other activity, either good or bad. And that's what we've been trying to define. How does this long non-coding RNA called Borg regulate triple negative breast cancer progression? So metastatic progression, and particularly metastatic relapse. We were able to show in a paper about 3 years ago now that women, after their final treatment, they've got that relatively short window of time, a 5-year window before they recur. Women who made it through that window didn't have Borg, detectable levels of Borg. Women who recurred had very high levels of Borg. So we're still trying to unravel how it's working, and with the ultimate goal of trying to target the major pathways that are downstream of Borg.
So is assessing for Borg relatively easy to do? Is it something that could be done on a blood test, on a liquid biopsy? Because I could see that being a great biomarker for who may need increased surveillance in the future?
Yeah, I mean, we detected through PCR. So I mean, again, everybody's familiar with that, and with all the COVID testing like that. I don't see why it wouldn't be able to. I mean, we're gearing up now. We've actually had our Center of Biotechnology that will help us start to do some single cell analysis. Unfortunately, it arrived and then right when COVID started, and so we're still trying to get access to the machine, get properly trained on it and stuff. Even a year later, people aren't allowed on campus yet to come do some of that. But that's one of the goals that we're trying to do. We're trying to see how early in development in women with disease can we detect it. I mean, early in terms of when they're first diagnosed, and can we use it as sort of a surrogate to predict, as you're saying, even a blood test in women who are in remission, to if you can find these circulating tumor cells, can you find Borg, which would be a strong predictor of a potentially negative outcome. So,
and I mean, I could see it being potentially used both in the early stage to identify who's at risk for metastases, but maybe even in someone with already metastasized disease who may be stable, and to see whether it, like
right.
other things, CT, circulating tumor cells, cell-free DNA, may predict who is going to have progression before our imaging picks it up.
Right. Yeah, I think it'd be far more sensitive. So that's some of the goals and where we're trying to get to in that regard. In addition to the basic biology, how does this thing work?
Right. And what does it do? How does it work? How can we exploit this to arrest it or make a difference in the dormancy or waking up from dormancy of metastatic cells? Yeah.
Yeah. We have another follow-up paper. It's clearly essential for breast cancer stem cells to have that stemness. They're resistant to chemotherapies. We've actually published that, but so it's definitely there, and we're working harder to understand it regulates RNA splicing, splice variants, everything that the farther that we get into this, the more and more interesting it gets at multiple levels. And I think there'll be a lot of potentials to target from different angles to take out Borg action, not Borg itself, but Borg action. So,
and that's one of the things I think is frustrating, certainly for those of us living with metastatic disease, is that we don't understand it. There's so many things we think science understands everything, and I think a lot of us may and there's a public misperception that breast cancer is no big deal. I don't know how many times I've had people say to me, "Oh, breast cancer, like that's no big deal anymore. Like they've cured breast cancer." And it's really frustrating because we expect more, and that's one of the things that Metavivor believes in so passionately, is that not only do we need the clinical trials and the things that we can get treatment for in a matter of months or a year or so, but we need that basic research that could lead to those interventions in the future. Because if we don't understand why cells can become dormant and stay in our systems for years and years and years, decades, even in the case of estrogen receptor positive disease, and then be reactivated later, then how can we possibly think that we can intervene?
Right.
So, from the patient standpoint, it's frustrating, but when we're, even as humans, as a mom, my kid didn't run until she learned how to walk.
Exactly.
She didn't walk until she learned how to crawl.
Yeah, I mean, I think a lot of what we're trying to do is just define the basic rules of how the game is played, and it's a challenge, but it's exciting every day too, because we're learning more and more, and going in areas that we didn't see we were doing even 10 years ago, which I think is really always exciting too.
And the other thing I'd like you to maybe touch upon, you mentioned that you have an R01 grant. So I'd love to learn a little bit about how a relatively small grant like a Metavivor grant can help you get those bigger grants, and what exactly an R01 is for those that aren't spending half their days reviewing LOIs, letters of intent, and grant applications.
Yeah, so in terms of your first question, oftentimes we have a great idea, but in order to get that idea in motion and get it the train sort of rolling along the tracks, we need some seed money just to perhaps recruit a half-time person to come in and help, or move somebody to shift. We need reagents. We have to build some systems. that money is essential for those aspects, as well as giving us the preliminary data we need to support a bigger grant. I mean, the reviewers are always like, well, what about this? What about this? And so you have to build a story. And it really is like saying, once upon a time, we discovered Borg does, and you have to sort of people walk the reviewers through it. Pilot money is essential for building these types of stories. A lot to sort of craft a grant to get not just data, but compelling data that people really can believe in. They oftentimes too, I can't tell you a number of times, seed money has directly led to publications. I mean, we've credited Metavivor for 5 or 6 different, maybe even 7. I have to go back and look, but publications that came out of that. But it's almost like a tree coming out, and you get a new branch and a new branch, and these studies start to take off. And so that's where it's really essential to help do that. And it's critical. It's really, really difficult because a big grant like an R01, it's an investigator-initiated grant from the NCI. The budgets can be, from $250,000 to $500,000 a year, for up to 5 years. They're very competitive. They're really hard to get in the current funding climate, and we have to be roughly the 7th, 8th, 9th percentile or better. So it's very difficult. So having the seed money really puts an investigator in a position to craft a much better grant to go in with and be competitive. That if it doesn't get by that time, you're in likely really good shape to get it the next time. You have to modify it, improve it a little bit, but that seed money is essential for those steps.
And and that's why we do what we do. And the people that are going to be watching this, those $5 I'm not going to have my Starbucks today, those Facebook fundraisers, the big events like the Mets grades, those all fund this kind of research. And last year in 2020, in the middle of the pandemic, when very large, very pink organizations chose not to fund any new research, thanks to people like you that are watching, we were able to fund researchers to the tune of $4.4 million.
Nice job.
We're super proud of that.
Yeah, you should be. You should be.
And I'm hoping that, by getting an update on the research we funded in the past, like your research, which is really exciting. I've read your abstract. I've read your final summary to us. I have some of your papers bookmarked to hopefully find them not behind paywalls. That's super exciting.
I can send them to you. Yeah.
I'll email you on the ones I can't find. But that's super exciting. And that's the whole reason that we're doing this virtual talk with the researchers we funded, is to show everyone how important it is, and to hopefully generate more funding so that in 2021 we can fund 5 million or 6 million, or maybe someday we can be up there and funding 10, 15, $20 million in research. Because
that'd be fantastic. Yeah.
Yeah. And right now we have, since you got your grant, we have increased the amount of our awards. Our early career investigator awards are now 100,000. Our translationals are 250,000 for a 2-year period. I wish we could do 250 a year for the 2-year or 3-year period of a grant, but we're not quite there yet, because we want to keep funding people like you who are doing such important work that is going to make a difference in our understanding of metastatic breast cancer and the eventual development of treatments so that this can become a chronic disease, which by my definition, I hear people now, some clinicians even saying metastatic breast cancer is chronic. We have people living 5-10 years. I'm sorry, that's not chronic. Chronic is allowing us with treatment to live a decent quality of life for at least close to a normal life expectancy, like people with HIV, like people with diabetes.
Yep. Yeah, that's one of our goals, and that's one of I think the attractive things about studying dormancy is, again, we don't understand what takes a cell that's dormant and makes it wake up, but we also don't know how to put it back to sleep. And if we can decipher those two pathways, that's what goals. Be able to administer to patients that would allow those things to go back to sleep, and they would die of old age, heart disease, some other thing that you would sort of expect as you age, as opposed to your cancer. So,
right. So, is there anything that the metastatic breast cancer community can do to help you with your research, whether in terms of patient specimens or a little pressure on the powers that be to give you more funding. So, you know,
well, I mean, definitely funding support would be the greatest thing that, you know, I mean, it's, you know, we get an award and when they always get cut right away. And so we're losing personnel. It's just, you know, I understand some of the rationale behind what they do, but it's essential to keep the momentum going. I actually think there's, you know, with organizations like Metavivor, you guys have, you know, really done what you're saying, pressuring them. And there's been more of an awareness, even from the NCI, that you know, we have very little in their portfolio that's directly specific. And I think that's key to keep getting that message out, right? It's, if we're going to make a real dent in this, we have to really improve early detection. I mean, when you're talking about starting to screen women much earlier than normal, or understand metastasis, how does this happen? How can we target it? You know, what can we do to just wipe this and alleviate this part of the disease out? And that's, I think, we're money, and then keep pressuring the government they're starting to realize that this is really, really important now.
Yeah, I mean, one thing that COVID has shown us is that if you throw enough money at something and you make people cooperate,
Yeah,
and share data and work together, that amazing things can be accomplished in an unbelievable, mind-blowing short amount of time.
yeah, it was staggering. Yeah.
So once we, you know, we kind of get through this pandemic and we return to a more normal life, you know, I'm certainly hoping that that same kind of focus can be turned towards metastatic cancers of all types, because I always say that as someone with metastatic breast cancer, I have more in common with somebody with metastatic lung or metastatic colon or metastatic melanoma than I do with an early stage breast cancer patient.
Exactly.
And
Yeah.
you know, if we throw that kind of energy and focus and money and absolute cooperation at metastatic cancers, you know, I think we can make it a chronic disease, you know, hopefully in the lifetime of those that are watching this, including me.
Yeah, that's the goal. That's
Yeah.
what we're trying every day. So
So I just want to end this with a brief question to you about how has COVID impacted your research? You mentioned that you got this cool new piece of equipment and you haven't been able to use it yet because nobody can come onto campus to teach you how to use it.
yeah, I think that's been sort of that, and so you're filming this. Our university sort of, we shut down, but they suggested that we work from home, but we never had a strong command saying we couldn't go in. So we, you know, kind of, I don't want to say we snuck in, but we showed up every day. We tried to treat, you know, for early stages of the pandemic every day like a weekend. So people come in, just get what you have to get done in the laboratory done, go home and do data workup right at home, do that type of stuff. So, and stuff that we could control within our domain in the lab, the general day-to-day stuff, we were able to kind of keep a lot of that stuff moving. Unfortunately, some of the high-end technology stuff where, you know, where we use university shared resources, some of the sequencing cores, the animal work all came to a stop, and that has really set us back, and we're still trying to catch up with some of that now. And again, with this new technology, I mean, one of the goals was to get, you know, blood from patients before treatment, after treatment, look at CTC, start to do single cell sequencing on them, do those types of studies, and all of that was delayed because of the COVID. So,
right, you know, not only that we couldn't get into the lab, but we as patients, our treatments were being delayed. We, you know, we were doing a lot of things. I did not see any of my, neither one of my oncologists, my primary care physician, my palliative care doctor in person for over a year.
wow, it's crazy.
Everything, and because I'm stable, I didn't have to go in. I'm not on infusional treatment right now, but every visit was via telehealth. And so, you know, it's hard to give blood through telehealth, although living in Lake Tahoe, and, you know, since you spent 4 years in Reno at UNR and you have family, you know what Tahoe's like.
Yeah.
I can order a book on Amazon and have it delivered the next day.
Yeah.
And so if we can do that, then we can have blood drawn locally and sent to the institution. You know, so there's ways to get around it. And I think that is another thing that I hope lasts after COVID, is that the idea of decentralized trials, meeting patients where they are, and that includes in the research space, that can hold so that we can accelerate the pace of research, like what you're doing, that relies to some extent on patient samples.
Yeah.
Because believe me, I would gladly ship a tube of my blood to you from California to Ohio.
Well, we take it. So, yeah, we're like I said, we're really close. We've got everything sort of set up, and we're starting to play with some, test experiments now before we go on the real samples. But we're really close to finally getting it up and running. We're excited about what holds in the future for us. So,
yeah. Well, we're excited to see where your research leads, and we are grateful for your time in talking with us today. And every time I speak to a researcher, I always remind them that, just because you got one Metavivor grant doesn't mean you can't get another one. So look out for our RFPs, and I look forward to seeing the research that you continue to do. So
okay. Thank you so much. Yeah, we really appreciate what you guys do. Thank you.
Thank you.